All right, great. Let's get this out of the way. We can all see the screen?
Yep.
Kiana, you can see the screen? Sorry?
I can just see your little icon. I don't know.
Right.
Yeah, I don't see your screen. I see your icon.
Oh, yeah, there we go.
Now?
Yeah.
Yep.
All right, beautiful. Okay, so we're starting with trig today. Well, new topic. Here we go. So the first thing we've got to do is learn our exact values for our trig functions. So exact values for our trig functions. Now, if you've got your calculator out, we're going to find the exact value of sine 30. So place sine 30 into your calculator, and it should give you a whole number. It should give you half. Not a whole number, sorry. It should give you an exact value. Do we all agree with that?
Mm-hmm.
Yep.
All right. The next one says cos 30. So we'll place cos 30 in our calculator. And what it would say is 0.866, and it goes on forever. Now this is not an exact value, right? Now what you're going to learn at school is the exact value triangles. And you might have learned that last year. I don't really reckon they work very well because you're going to get numbers now that are going to be really large, like 330 degrees and angles that are larger than a triangle. So what we are going to do with something like this, to make it into an exact value, we're going to do this trick. We're going to square the term that you see in your calculator. So if all of you are still at 0.866, just press the squared button now. And what you should get is 0.75. Did anybody not get that? All right, great. So 0.75. Then we would press the fraction button, so SD, and that becomes 3/4. Are we all up to that stage now?
Yeah.
Daniel?
All right, how'd you get 0.75?
Square it. You got to square this term. So you press cos 30 in your calculator, press equals,
Yep.
and then square that term. Are you there yet, or stuck?
Yeah.
Yeah. All right. Press cos 30 and press equals. What do you see?
Yep. 0.866.
All right. There we go. You're here now. Now square it. So press squared.
Yep.
And then press equals. What do you see now?
Syntax error.
Did you actually just put cos 30 in your calculator and then press squared? It shouldn't give you syntax. Daniel, go on to webcam. Show me. Oh, Radji. Rad, you here? Yes. Daniel,
Yeah, bro, what's up?
Wait 1 second. Daniel, show me your calculator again. All right, beautiful. All right, go. Cos 30. Cos 30 equals. Now press square. Squared. No, that's root. Square. There we go. 0.75. You were square rooting. All right, you can go off webcam again. All right. Brad, you were here when I was talking about the trig functions?
Literally joined maybe like a couple minutes ago. I got up to
Okay.
the part where you started saying, oh, we square it, and then you mentally square root it or something.
That's it. That's great then. So 0.75.
Yep.
We're up to this stage now. Then we obviously press SD. We will get 3/4. Now what you want to do at this stage is mentally square root it. So the mental square root, the way that works is if I just did this in my calculator, I mean, you guys are just going to get back to 0.866. So that's useless. Mentally square root means you're meant to think about what's the square root of 3? Well, that's still root 3. And what's the square root of 4? That's 2. So So the answer to cos 30 in exact form is root 3 over 2. Again, what did we do? We got this answer here, and we are mentally square rooting it. So square root of 3 is 3, square root of 4 is 2. The answer we're looking for cos 30 is root 3 on 2. So this was a half, this one's root 3 on 2. Anybody not get what I've done there? Let's try another one then. Yep. I've got to talk. 10, 30. All right. Kiana, I'm with you, right? Ready? Kiana,
Yeah.
ready?
Yeah.
10, 30. Press
Alright,
equal.
10:30.
What do you see?
0.577.
Yeah, and it goes on forever. That's not an
Yeah.
exact value, right? So
Yep.
what we're going to do now is square that. So press squared. Press equals. What do you see now?
0.3 recurring.
Right? We don't want that. We press SD. So it becomes 1 over 3 right now, yeah?
Yeah.
All right. Now you're not allowed to just go and square something. That's like totally not allowed. So we've got a square root. Sorry, mentally square root it. So we've got to root this back now, but without our calculator. So in our head. So what's the square root of 1?
1.
1. And then square root of 3 is just root 3. So the answer we're looking for tan 30 is 1 on root 3.
Okay.
All right, now clear your calculator just to double check it. Watch this. Put this in your calculator. Put 1 on root 3 in your calculator.
It gives us the original answer of 1030.
That's it. That's what we want. The original answer for 1030, but at least this is exact now, right? No decimals. Great. Let's go again. We're just going to keep doing one by one. Lisa, sine 60. It's all yours. So sine 60.
Okay.
You get 0.866. Then what are you going to do with that?
Square root it.
Square it, you mean. Square it first.
Yeah.
Square. That gives me 3 over 4. Then what's your final answer that we're looking for?
The 3 over 2. Square root 3 over 2.
3 over 2, because you've got to mentally square root this. Beautiful. Double check it. Put that in your calculator. Put this in your calculator. Should give you the exact same answer. All right, beautiful. Yes, everybody's with me. Daniel, it makes sense now?
Yeah.
Rad, makes sense as well?
Yeah, bro, all good.
Done. Okay. Cos 60. Plug it into our calculator. What does it say straight away?
0.5.
0.5. Well, that's just half without doing much more work. So cos 60 is easy. That's just a half. You don't need to do anything to that. So if it gives it to you exact straight away, then you'll just leave it as the way you would see it, I guess. Tan 60. Plug it into your calculator. 1.73. Rad, it's all yours. Tell me. 1.73 I don't like. What am I going to do to it? Tan 60.
1060. Give me a sec.
Yep.
1060.
1.73. What do you do now?
Is it 3?
Yep. So square it becomes 3, which means the answer we're looking for is what?
Root 3.
Root 3. See, if you guys are seeing this trick, this square trick, it's something I made up. So you're not allowed to do that. So because we're not allowed, we have to go back again, which means we've got to root it again. The reason why I do this trick is because you need to know it. You need to know these numbers for really large values of angles, which doesn't work for triangles. This is larger than a triangle. Good. Tan 60 is root 3. Great work. Sine 45 becomes 0.707. Square it. Should give us a half. Square root it. You get 1 on root 2. Can everybody confirm that's true?
Yep.
Yeah.
Done.
Yeah.
Cos 45 Actually, same answer. If you want to memorize that, sine 45 and cos 45 are the same. Tan 45, if you want to plug that into your calculator, it will actually just give you 1. So you don't need to do any work for that. Super easy. All right. Lisa, this one's yours. Let's do all the 120s. You ready?
Yeah, all the 120.
Yeah, ready? Here we go. Sine 120. What does it
Sine
give you?
120, 0.866.
Blah, blah, blah. Yep. Square it. Root
Yep.
it.
Yep.
What's your
Yep.
answer?
It's just square root 3 over 2.
Done. You're starting to see a pattern.
Mm-hmm.
There's not many of them. So here we go. Cos 120. Do the same thing. What's the actual answer straight away?
Hang on. Negative 0.5.
Which means it's negative half as a fraction. Yep.
Yep.
There's no
And
need to
you
square it. You don't need to do nothing.
Okay.
Yep. Do you understand why we don't square that one?
Because it's already a fraction.
Yeah, pretty much, right? It's already it's a decimal that ends. So 0.5 ends straight away. Whereas when we did this 0.866 blah, 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 it doesn't actually end. It goes on forever. So tan 120, last one. Tan 120, negative 1.73. Negative
Yep.
1.73. All right, go tell me what your answer is.
You square it and then it's 3 and then it's root 3.
It is, but can you see there's a little problem? When you square this, obviously, it's going to give you a positive number, right?
Mm-hmm.
But you have to remember the original case was,
So it's negative square root 3. Okay.
You see, unfortunately, again, like I keep saying, I made this up. It's just a quicker way of doing stuff. But because it's not flawless, there's going to be cases that you got to keep an eye out for. But it makes sense. I mean, the answer was negative, and you got to keep in mind that the answer should still be negative here. Good. Tiana, let's do the next one.
Alright,
Sine
so
330, straight away, plug it into your calculator. In fact, it'll give you
Like 0.5.
half. Yep.
Then I
Close
square
it.
that.
No, you don't need to. See, since that's a fraction already, it's perfect. It's done. You leave it. Cos 330.
It's 0.866.
Just out of curiosity, press that SD button. Does it give it to you as a fraction?
One sec. No.
And that's why we have to square this one. Whereas the first one you did here, 0.5 actually becomes a half. So you don't need to go ahead and square it or anything like that.
Alright.
All right, so you're here, 0.866, we're going to square it.
0.75, which equals it's negative square root 3 over 2.
It isn't negative still, right? It should just be positive.
Alright.
Because put cos 330 in your calculator, what did it say? Did it say positive or negative?
Oh, it was positive.
It was positive, so you don't need to put a negative in front.
Okay.
Tan 330. Watch out, what does it say?
Negative 0.577.
Negative 0.5. All right, keep going. Square it. What's my final answer?
There, it's 1 over 3, but square root the 3, and it's negative.
So, would you agree
One
with
over
that? What
3?
I've written? Negative 1 over root 3.
Yeah.
Good. Daniel, you ready for this last one?
Which question? Question 2.
Last one right here.
Oh, sine 225.
Yep. So sine 225. What does it say?
0.70.
Yep. Negative, right?
Yeah.
So square it
0.5.
and then press the SD button.
Oh, 1 on 2.
And then, yep, 1 on 2. And then what's your answer? 1 on?
Root 2.
Root 2. So easy. Cos 225. looks exactly the same as sine 225.
Yeah.
So it's just negative 1 on root 2. Without doing much more work. And then do tan 225.
It's just 1.
Just 1. Everyone's happy with that?
Yep.
Yeah.
So like I said, this is getting recorded anyway, so you get to go back, you can start it and stop it. And you'll get the field off right after we're done. Okay. That's not the question 2 just yet. That's the question 3. Okay. Find the exact value of x in each diagram. Exact. Are we allowed to have 0.866421334 blah blah blah? No. Exact means it has to be a fraction or a whole number or an integer. Okay? Or a surd. All right. We still remember our right angle trig identities here? Make this bigger. Sokotor. All right. Find the exact value of x in each diagram. What are we going to use? Opposite over hypotenuse, which is sine. So it's going to be sine 60 equals opposite over hypotenuse. The exact value of x times the 8 over. Yana, Lisa, does that make sense what I've done there?
Yeah.
Now,
Yep.
the mistake that everybody would make with this question is they would place all of this into their calculator. And if you go ahead and try that, it'll give you an answer of about 6.928.
Mm-hmm.
The problem with that is that will never become an exact value. So what you're meant to do is ignore the 8 and just put sine 60 in your calculator. So go ahead, put sine 60, becomes 0.866, we square it, we root it, becomes, hopefully once you guys confirm, it should become 8 times root 3 on 2. I'll stop there to make sure everybody's on the same page. Let me know if you can't get to that stage. Yep, everyone's happy with that?
Yeah.
Please do not put the whole, if you're ever trying to find exact value, you're meant to not put the whole thing in. Like if there's an 8, if there's a 10, a negative, whatever, you just put the trig identity into your calculator, because that's the only thing you're allowed to square and square root and everything like that. All right, perfect. What's the final answer? 8 divided by 2. Why am I allowed to do that? Because I multiplied. Final answer for x is 4 root 3. Any questions there? All right, let's do this one. This one's going to be adjacent over hypotenuse. You're obviously going to pick cos equals adjacent over hypotenuse. In this case, when x is in the denominator, you swap your trig, so it'll look like this. And then again, we don't put the whole thing into my calculator, you only put the cos 30 in. Cos 30 becomes 0.866, which again becomes root 3 on 2. Just double check that, see if you agree. Okay, anybody not agree with this line here? All right, beautiful. So then, to be able to divide this, the easiest way is to go 12 divide root 3 on 2. which means that becomes 12 times 2 on root 3, right? We multiply and flip. What's the answer I'm looking for? 24 on square root of 3. That makes sense to everybody? Daniel, does that make sense?
Yep.
Yep. Any questions? Any lines that you want me to confirm? No? All right, I'll leave that with you guys. I'll leave question 4 for homework. It's exactly the same. It's just broken up into like maybe 2 or 3 different sections. To show that dp, this bit here is equal to 6, you're just going to do, for example, that would be x, opposite of a hypotenuse. Show that AP is 6 root 3, show that this guy is 6 root 3. You could do adjacent and hypotenuse, you could do opposite and adjacent, you could do Pythagoras' theorem, whatever. I'll leave that with you guys to do. And then there's work solutions. All right. Trig identities. Let's start on this. Probably the most important with equations to understand for trig. So the rest of what we're going to do, which is like sine rule, cosine rule, and area of a triangle, it's basic stuff that you've done before. They're not too hard, like these things here. They're just formulas. You're just going to plug them in and they're going to be really straightforward to do. Cosine rule, same thing. You're just going to follow the formula. The hardest things in trig for advanced students is just understanding these equations, which is your quadrants, and proving your identities. So before we start, we've got to go through all the different formulas you'll need. So what I'm going to do is actually start a new page and write all the formulas so you can have that as your little formula sheet. All right, here we go. So we know we've got our 3 sine, cosine, and tan. We've got some newer ones as well. We've got something that's called sec theta, cosec theta, and cot theta. Has anyone actually heard of these 3 or know what these 3 are?
Yep.
Yes? Daniel, you have? What are they? What's sec theta equal to? Do you know? No?
Hold on, who are you asking, Sam?
Sorry?
Who are you asking?
Who said yes?
Me.
Okay, sorry, Rad, go ahead. Do you
So is
remember
that
what
one
sec?
of cos?
Yes, beautiful. So sec theta is 1 on cos theta. Cosec theta is 1 on
Sine theta.
sine theta, and cot theta is 1 on
Yeah.
tan theta. All right, beautiful. Girls, have you learned this before?
Yeah, but I don't remember it.
I think
So the
he
way
taught
you
it to me, but yeah.
Okay, the way you do remember, it's very straightforward. The third letter of this must be the first letter here. So sec, third letter is C, it's 1 on cos. Cosec, third letter is S, 1 on sine. Cot, third letter is T, 1 on tan. Easy to remember?
Yep.
Yeah.
Tan theta is also sine theta on cos theta. So tan theta is also sine on cot, which means cot theta is also cos on sine. So cot theta is cos on sine. One more time. Tan theta is sine on cos, which means cot theta would be cos on sine as well as 1 on tan. So it just depends. Sometimes you're going to use this. Sometimes you might have to use this. And you'll know which one to use when required. On top of that, there are technically 3 more, but most students just memorize 1. Sine squared theta plus cos squared theta must equal to 1. So sine squared theta plus cos squared theta equals 1. From that, you get the other two. But most students just memorize this, like I keep saying. But from that, you can get, if you want to just solve for sine squared, you can minus the cos squared over, and you'll get this. If you want a cos squared, that becomes 1 minus sine squared. You would subtract the sine squared over. All right, let you just look at that for a few seconds. Let it sink in. Have we written that down by now?
Yeah.
Yeah.
All right,
Yep.
let's go. Go and start these questions then. So we've got to use these identities when we're trying to answer these such questions. What am I to do that? Over here. Paste it here. All right, beautiful. Here we go. A. The question is just simplify right now. So simplify cos theta tan theta. Cos theta times tan theta. Well, what do I know about tan theta? What is tan theta equal to?
Sine over cos.
Sine over cos. What am I allowed to do with the causes?
Cancel each other out.
Come sine theta. Lisa, that was easy.
Yeah.
Let's do B. Cot theta. What is cot theta equal to, Lisa?
Cot theta is cos over sine theta.
Yeah. Tan, sine over cos, cot, cos over sine, or 1 over tan. Now, if your question, like which one should you use, you see how this one's got a sine next to it? Well, if you had chosen 1 over tan, you're not going to be able to simplify that, right? Doesn't really help. But if you had chosen cot as cos over sine multiplied by the sine, in this case, again, their sine thetas cancel out, you'll be left with cos theta. That makes sense?
Yep.
All right, Daniel, your turn.
Um,
1 minus sine squared. What is it equal to?
Sine squared. Isn't sine squared equal to 1 minus cos squared theta?
Yes, but then isn't 1 minus sine squared theta also equal to cos squared?
Yeah.
So then what does 1 minus sine squared theta become?
Wouldn't know.
It'll just become cos squared. So let's look at this again. Sine squared is 1 minus cos squared, but cos squared is 1 minus sine squared. So if I've got 1 minus sine squared, that can just become cos squared. If I've got 1 minus cos squared, that would just become sine squared.
Uh-huh.
Make sense?
Yeah.
D. Rad. 2 sine
What,
squared plus 2 cos squared. Yep. What does your gut instincts tell you to do when you see something like this? 2 and a 2. Everything
Take
you've
it
been
out.
everything you've been doing in the last few weeks. Factorize it, take
Yeah.
it out.
Back out, yeah. And then just make it equal 1 then. Which
And what
equals
does
2.
sine squared plus cos squared become?
2.
Just 1, which is 2.
Yep.
Right, sine squared plus cos squared. Everybody look. Sine squared plus cos squared equals to 1. Any questions about that one? Girls, anything?
No.
Okay.
Makes sense? Cool. Daniel,
Yeah.
makes sense?
Yep.
All right, let's go. E. Again, let's say, Lisa, what would you naturally do with a question like this if you see two brackets? What is your head telling you to do?
Difference of two squares.
It is actually a difference of two squares. Good job. So, and if it wasn't, let's say, a difference of two squares, what's the word I was looking for? Starts with E.
Expand.
Yeah, just to expand, but you even realize it's a difference of two squares. But do you know what the answer of this is if it's a difference of two squares? 1 minus
Cos theta.
cos, can't just be theta,
Square theta.
squared, right? It's got to be squared. Isn't that the whole idea of difference of two squares?
Yeah.
1 minus, beautiful. And then what does 1 minus cos squared theta equal to? Lisa?
Sine squared theta.
Yeah, not too good. Sine squared theta. Done. F. Brad, your turn again.
For F,
Yep, 1 second. Again, what does your head tell you to do when you see something like this?
factor out sine theta.
Factor out sine theta. And then you're left with
Sine squared theta plus cos theta.
what does sine squared plus cos squared equal to?
1.
1. So 1 times sine is just sine.
Yeah.
Does that make sense to everybody else?
Yeah.
Yep.
Okay. Let's let's do the proving questions now. All right. Now, these questions. A. Prove the following. The square root of 1 minus cos squared theta equals sine theta. Now, the biggest mistake everybody makes when they're starting a proof question is they think they have to write both of these out. You're not allowed to write both of them out. The technique works like this. You have to start with left-hand side or right-hand side, usually left-hand side. So we'll say that LHS, left-hand side, equals square root of 1 minus cos squared. And then what we're trying to do is get this eventually to become sine theta. Tiana, let's do this together. Square root 1 minus cos squared becomes square root. What does 1 minus cos squared theta become?
1 minus cos theta.
Nope. Nope. You can't square root it like that.
Alright.
So 1 minus cos squared, you've got to use these identities all the time. What does it become?
Oh, sine squared theta.
Yeah, that's it. You have to make sure when we finish off today, for example, this is memorized.
Alright.
So, and to all of you, I mean, personally, I would really love this opportunity if I was at your year and I didn't have to go to school. I would really take this opportunity to actually like accelerate in next term's work, the term after, so then that way when you do start school, you're ahead of the class, you're ahead of the year. I would actually really capitalize on this time. 6 hours a day, 5 days a week, 30 hours of work you can actually do now that you're not wasting at school. So I don't know. I would really start looking into accelerating for all my subjects. But here we go. 1 minus cos squared. We said becomes sine squared, and only now are you allowed to square root it. All right, Tiana, you can't square root it if there's a plus or minus. Same thing as canceling. You can't cancel a plus or minus out like this. These don't cancel. That's wrong. So same thing with this. You can't square root and split them up. So now you can, this becomes just what? What's the square root of sine squared theta become, Kiana?
Theta.
Sine
Sine theta.
theta, which equals right-hand side. Does that proof make sense to everybody?
Yep.
Daniel, yes, makes sense?
Yep.
All right, let's go. We're going to start with B. If you couldn't start with your left-hand side, you are allowed to start with your right-hand side. If you couldn't start with your left-hand side nor your right-hand side, then there's something wrong. You've done it too hard. Or you could use the question and then get to a result and rewrite it backwards. But we'll get to those questions as we come across it. Brad, you ready for the next one, please?
For B, yeah.
Yep, the left-hand side becomes sec squared theta, open bracket 1 minus cos squared theta. All right, we'll start with the 1 minus cos squared because I think we all know the answer. What's 1 minus cos squared become?
Sine squared theta.
Sine squared theta times sec squared. What would sec squared be written as?
1 on cos squared theta.
1 on cos because it's sec, but you've got to write squared this time because it's sec squared. And then that, when you multiply, you're just going to go straight across. Simple fractions. And then sine squared on cos squared becomes?
Oh,
Say it again.
Hang on, I just forgot that.
No, say what you said because I heard it. Did you say change the sine squared to 1 minus cos squared?
2.
Is that what you said? Rad.
No, I said I forgot to simplify. I'm like, can you simplify it further?
Oh, okay. Yeah, how would you have simplified that further? Just by getting
I would
into
have
a
left
tan.
that. I
Sine
forgot
over
about
cos.
the
But you know why you wouldn't have left it? Because look, what's the question? Prove. And you're meant to prove the right-hand side becomes a tan. So you would have looked at this, and then you would have gone, oh yeah, it's obviously a tan.
Yeah.
C. Everybody else, did that make sense what I've done there?
Yeah.
Yep.
Please, the working out's very important, right? You have to write LHS. You don't start with the question. Except for exceptional cases, which we will do them shortly. But 99% of the time, it's LHS to prove RHS. All right, tan theta. Sorry, what am I writing? Left-hand side. Tan theta, square root, 1 minus sine squared. All right, Lisa, it's all yours. Here we go. Tan theta.
Yep. Tan theta,
What does
and
it
then it would just be times cos
what is-
theta.
Yes, wait. What does tan theta become?
Tan theta becomes sin over cos.
Sine theta on cos theta, great. Square root, 1 minus sine squared. What does 1 minus sine squared become?
That becomes cos squared.
And then, as you were saying, the squared and the root cancels out, and you're left with cos theta only, right?
Mhm.
And then cos theta on the top, cos theta on the bottom. What are you left with?
Sine theta.
And what were you meant to have?
Sine theta.
Equals RHS. Great work. You're doing well. Daniel, next one's yours.
Yep.
D. LHS. LHS. All right. Cot theta plus tan theta. And we've got to try to get it into cosec sec. Oh, that's going to be a little bit tricky. Let's see. Daniel, what are you going to say for cot theta? What does it become?
1 over tan theta.
It does. I don't want to use that one.
Uh-huh.
What's the other one?
Cos theta over sine theta.
Why did I know to use cos over sine? Because I look at this guy, cosec and sec. Are they in terms of tans, or are they in terms of sines and coses?
Sines and coses.
Yeah, so that's how I know to change these to sines and coses instead of leaving them as tans.
Yeah.
Sense?
Yeah.
Plus tan theta. What does tan theta become? Sine theta on
Cos
cos
theta.
theta. All right. Everybody still with us?
Yep.
Yeah.
Now, Daniel, what are you going to do? This has a times, whereas you still got a plus. So the logic is we've got to do a common denominator here, right? Just like you were doing back with algebraic fractions. What do you know what your common denominator is going to be?
Cos theta.
No, that's not right. Lisa, do you know what your common denominator is going to be for this fraction?
Would it be sine theta cos theta?
It would be, yep. It's got to be, Daniel, it's got to have both denominators in there. So sine theta and cos theta. And then what's missing from this sine theta and this sine theta cos theta? You're missing an extra cos theta. So you're going to times that to the top. That becomes cos squared. Plus cos theta and sine theta cos theta. You're going to times this one by sine. We'll stop there. Make sure we're all on the same page. Brad, does that step make sense?
Yeah, all good.
Yep. Lisa?
Yep.
Yes?
Yep, all good.
Yep. Diana?
Yeah.
All right. Sandra, I know you're there, but I know you're on chat. I think this is okay for you because you would have done this already last year with me. Can you just confirm that you're all good with this as well, please? Daniel, makes sense what I've done so far?
Yeah. Yeah.
Yep.
Yeah.
All right. Cos squared plus sine squared, what does that become? 1 on sine theta cos theta. And just to finish it off, 1 on sine was, what does 1 on cos become?
Cosec?
So 1 on sine is cosec, 1 on cos is sec.
Oh, okay.
So therefore you're left with cosec theta times sec theta, which is exactly what we needed to prove. Which equals right hand side. Any questions, you guys?
No.
All right, let's go with E. E, sec theta minus, okay, here we go. If we get into the LHS. All right, left hand side. Johnny, you want to try this together?
Yeah. One sec. Sec theta. So left hand side 86.
So what's the first thing you're going to do?
Make it 1 over cos theta.
No, not yet. Good idea, but not yet. Look at this. Look at this. Everything you've been doing in term 1. What would you do first?
Take it out.
Yeah, take it out. That's it. If you can, if you say, hey, let's change this to 1 on cos, this has to become 1 on cos, and this has to become 1 on cos, right? Whereas if you just take it out, you're only going to write it once now. Can you see how you're only going to write 1 on cos once?
Yeah.
This makes it a bit easier, believe me. Okay. Diana, sec theta, what did you say it becomes again?
1 on cos theta.
And 1 minus sine squared theta becomes?
1 minus cos theta.
No. Incorrect.
Cos
One
theta.
minus
Cos
cos.
theta.
Cos squared theta. I get some getting used to. Cos theta and this squared will cancel out. And you're left with cos theta, which is RHS. Yep, that makes sense. Everybody, all good?
Yep.
All right, let's do F. I'm just going to scroll it down. F, sine theta on 1 plus equals 1 minus cos on sine. Brad,
Yeah.
this is yours. All right. So look, you can't. We've got to agree with something, you guys. Like you got to look at the question. Look at A. You probably can now tell. All right, yeah, that's not that hard. You can do that, and I can get the right-hand side. This one, same thing. You're like, okay, yep, I can change that to 1 on cos. That becomes sine, and I can eventually get tan. This one, I get it. 1 minus sine squared becomes cos squared. Tan becomes sine on cos. Cancel some stuff out. Should work out. Same thing with this guy. Same thing with this guy. Now, when you're looking at F, you've got to agree. Can you do anything to sine theta? Do you have any formula for sine theta only?
No.
No.
Do you have a formula for cos theta, or 1 plus cos, or 1 minus cos, or sine? Like, are there any formulas for any of these 4 terms that you see here? No,
No.
actually isn't.
Would you cross multiply here?
You must do that.
Yeah.
But I just want to make sure everybody can realize to do that. Girls, do you see what he's like? Look, the problem is we can't do anything to this and this to eventually get this. It just won't ever work. Can we agree on that at least?
Yeah.
But whereas like this one here, if I just look at this question, it says cot and tan, and then I need to eventually get it to like cosec and sec, which is sines and coses. At least I know I can change these to coses and sines and do a bit of algebra and hope for the best, and it just works out. Whereas this, I can't do anything to this because I can't even change sine and cos to anything. So, keeping that in mind, the only way you can do this is by cross multiplying it. This times this becomes, so there is no left hand side, right hand side yet. So sine times this becomes sine squared. This times this becomes this. Which expands to this, difference of 2 squares, just like before.
Yep.
And hey, that's something we know is true, isn't it? Sine squared theta does equal to 1 minus cos squared. Now, Brad,
Yep.
you said cross multiply. We did it. I expanded it for you. I'm here. Does this
Yeah.
line now mean you proved this equals to this?
Yeah.
No.
Why?
The problem is you used the answer, or the question, sorry, you used the question to prove something that is true. What you're meant to do now, wait, let's go say that again. You guys, just so it's clear. You use the question to get something that is true, which is not wrong. It's actually the right way to do it. The other is you're not allowed to use something and then get something that you know is true and then go, therefore, I just proved that this side equals this side. Thank you. Well, no, you didn't prove this equals this. You just proved this equals this. So what you're meant to do now, so that would be the side of your working out. What you're meant to do is, now you know the first line you're meant to have. Your first line is this line here. So Rad, What's my first line?
The answer that we got.
Yes, so say it.
Sine squared theta
Yep. Equals.
equals 1 minus cos squared theta.
And now you know that's your first line. What's your second line going to be? This guy right here.
Yeah.
You're going to
they work
factor it.
back.
Yes, you're obviously going to work backwards. What's going to happen when you work backwards?
So and you're going to get the question.
Actually prove this.
Yeah.
Now, what does if I had to break up sine squared, you would write it like this, right? Sine theta times sine theta. Just so it can be a little bit easier to read.
Yep.
I'm going to stop there for a second. Daniel, girls, does this steps make sense so far?
Yeah.
Yeah.
Right? Working out. So that's your working out, but this would be the actual answer. This is how it's going to look. So now that you know, oh yes, okay, I got my starting point. That's meant to be my first line. I know where that came from, so that becomes my second line, which just means factorize this by a difference of 2 squares. I just wrote this up so it's a bit easier to see. And don't forget, all I need to prove is this. I'm literally one step away. I'm going to divide this guy over here, and then I'm going to divide this guy over here. What's my final answer? Sine theta on this guy, which equals 1 minus cos squared on this.
Yeah.
Are you
All
actually
good.
allowed to do that though?
Proven. Yes.
Yeah.
Ah, you are allowed to do that.
Sam, what's that hashtag over there?
Hashtag means proven.
Oh, okay.
So in mathematics, if you ever see me do something like that, it means proven.
Alright.
It existed before Instagram. Bad joke. All right, we're good. G. I'll leave that with you guys. It's really easy, but I just want to know if you know the first line. Tiana, what would you do when you see G? When you see such a question like this?
Expand it.
Yeah, good guy. That's all I needed to hear. Expand this, use the perfect square. Expand this, use the perfect square. What happens, because this is a minus, this is a plus, the middle terms all cancel out, and eventually you're just going to get like 3 squared, which is 9, plus 5 squared, 25. 9 plus 25 will become 34. So I'll leave that one with you guys. It's easy. Let's move on to equations. Am I going too fast, or are we okay so far?
Good so far.
No, we're alright.
Should we do some more of those identities or move on to equations?
Move on.
Move
Yeah,
on?
move
Everybody ready to move on? Yeah? All right,
Yep.
Yep.
let's go. So trig equations. I think it's the third last new thing we have to learn, I guess. There's not much left for us to complete this topic. We do it in one day. Super quick. Am I going to be able to take a snapshot of this? No, not going to allow me. All right, cool. All right. Okay. Before we start on this, actually, I do need to talk about radian form and degree form. Radian form and degree form. The new syllabus requires us to write everything in radian form. The old syllabus, we were still writing them in degree form. Now, the way I will teach it to you would be to do everything in degree form. Your last line, you will convert from degrees to radians. Okay, so degrees looks like something like this, 30 degrees. Radians must become something like this. What we're going to learn now is how to convert from this degree to radians and radians to degrees. So let's do that. This is degrees, this is radians. Okay, so if I've got a question and the question was, let's do radians to degrees first. So pi on 3. Pi now becomes 180 degrees. So pi is 180 degrees. All right? So if I had to convert from this radian to a degree, all you would do is in your calculator, you would replace that pi for 180 over 3, and that should just become 60 degrees. Can everybody please confirm that?
Yeah.
Everyone's happy with that? Simple? I mean, I
Yep.
can give you more. I'll give you like, I don't know, 2 pi on 5. Can we get that as a degree, please? My answer became 72. See if your answer also becomes 72 degrees.
Yeah.
Yep, I got 1. Daniel, can't do it.
Yeah, I don't know how to do that.
You just, so on your calculator, press the fraction button first.
Yep.
Then press 2 times 180, and at the bottom, go down to your denominator, 5. Press equals
Wait, 2 times what?
180
Yeah.
over 5.
Yeah, 72.
Yeah, so every time you see pi, then you just change that to 180 degrees.
Yep.
So let's do maybe 2 more. Let's do y, do 3 pi on 5, and then IV to so Diana, do you agree?
Yeah.
Oh, Eden, are you in? Are you here?
Yeah.
Oh, I didn't know. Right. When did you join?
I think it was question E.
Like what did you, where did you start? Where did you hear me do the identity stuff?
I don't know. Question E was like sec theta minus sec theta sine squared theta.
Oh, this one.
equals
E.
Cos
Oh,
theta.
you're all
Yeah.
there. All right, that's late. Okay, no problem. I need to know, so at least that way with the next class, you can stay back and just listen to the beginning of the lesson.
Yep.
If you like, otherwise,
Yep.
I mean, like I said, this is actually all being recorded right now. So you can,
Okay.
if you want, you can just watch it. Everybody, you guys can just go back and rewatch it. Even when you're relearning it at school, you can just come back to the video and rewatch it. Make sure you download it. It's only going to be available on the Skype for 30 days. So try to download them. Okay.
Okay.
Does this make sense right now to everybody?
Yep.
Yeah.
Everybody's there? Cool. All right. Now, that was the easy one. So converting from radians to degrees is easy. The harder one is usually converting from degrees to radians. But here we go. So this is radians to degrees. This one's degrees to radians. Hi. 30 degrees. All right. 30 degrees. 30 degrees. The trick with this one is you multiply by pi manually, and I'll explain that in a second, over 180. So on your calculator, all you're going to do is this. You're going to put 30 on 180. That gives it to you as a 1 over 6. Then you put a pi on the top. So let's do that again. You're just meant to put 30 on 180 in your calculator. Let's all make sure we're all there. It should say 1 over 6. Do we agree with that?
Mm-hmm.
And then when you see 1 over 6, you just put a pi on the top.
Is it always on the top?
Yes, absolutely.
Okay, cool.
Always on top.
You got like
Everybody-
a 2 on the top.
Sorry, say it again.
If you got like a 2 on the top, would you put the pi next to the 2?
Yes, we're going to do that. Yeah, we'll do that. Don't worry. So if it was like, are you trying to say if it was 2/5?
Yeah.
Yeah, what would be the answer, of course?
2 pi over 5.
2 pi over 5. Yeah, you just put a pi on next to it. That's exactly right. Okay. Let's go. Double. Well, look, if you want to double check it, I mean, what does pi equal to one more time?
180,
180. What's 180 divided by 6?
30.
30. So it works out. It's just that that's the way it's got to be done. All right, let's try 45 degrees, please. Divide by 180. Should give you a quarter. So what's the answer I'm looking for?
I over 4.
Daniel, does that make sense to you?
Yeah.
Brad?
Yeah, bro, all good.
All good, all good. All right. Girls, everyone's fine. Tiana, Lisa, you're all good as well with this?
Yeah.
Yeah, all right, done.
Yep.
Triple A. Triple A. I don't know, let's go with a weird number. Let's try 120 degrees maybe. We'll try 120. 120 should give you that. I'll wait for Eden, you can give me the answer. Sorry, what was that?
2, 3.
Let's make sure. Yep, everyone's happy with that?
Yeah.
Yep.
Nice. Do we need to do one more? 4. Well, good luck, I guess. Always good to get even. Tiana, give me a number.
I have no clue. 135.
Any number. You literally have any, 135. It doesn't really matter. 135, all right, over 180. God, very nice number. 3 pi over 4. Everybody double check that.
Yeah.
Beautiful. So, like I said, with the old syllabus, they were happy with degrees, but now we've got to write everything as, that's not a good color. We've got to write everything as radian form, which would look like this, okay? So radians, you got to know that. Done. Let's get started with solving equations now. Okay. Okay. Now, before we can solve these, we do need to know our all stations to central. Did everybody learn this last year?
No.
No,
Yeah.
we've got one. Lisa, no. Anybody else that hasn't?
Yeah.
Learned all stations to central?
Yep. That's it.
Go on to
Okay. All would be theta. Sine, this is when sine is positive. So if we ever go on to say sine is positive, it's going to be in this region. Here, we're going to say all of them are positive in this region. Tan, and we're going to say tan is positive here, and then cos, we'll say cos is positive here. Now,
Okay.
This would be theta. This would be 180 minus theta, so this has to just be memorized. This one here is going to be 180 plus theta, and this one's going to be 360 minus theta. So you would write that down, you would memorize it. What we mean by the positive and negative is this. If I said, for example, I gave you a question, I said tan theta equals -1. Does that mean tan is positive or negative?
Negative.
Tan is negative. Where is tan negative? Tan would be positive here in its own region, and all of them are positive here. So tan would be negative here and here. Does that make sense to everybody?
Yeah.
Yeah.
Let's go again, a different case. And I said tan is actually positive 1. Let's get rid of that. Tan is just 1. Well, where would that be? Well, tan is positive here in P
Yep.
and in A.
Okay.
Let's do it again. Let's get rid of this and make it into a sine theta. Sine theta equals to √3. Is that positive or negative?
Positive.
That would be positive. There's no negative sign in front. That's positive.
So it's in S and A.
Sine is positive in S and A.
Okay, great.
Yeah.
So it's
Where
in,
is
it's
sine?
in whatever the letter is and A.
Pretty much. Where is sine negative?
In
C.
T
Where
and
is
C.
sine negative? It would be in T and in C. All right. We all get that?
Mm-hmm.
Yeah.
Once you what you do really need to memorize, because that bit there is pretty easy. What you need to memorize are these theta, 180 minus theta, 180 plus, 360 minus. Alright, so let's start solving this one here. Sine x equals √3 on 2. Okay. Step 1. Sine x equals √3 on 2. Step 1, we have to get rid of the sign. The opposite of signing something is to inverse sign it or shift sign. So x becomes shift sign, inverse sign, √3 on 2. Can someone give me the answer to that, please?
60.
60 degrees. Everybody else confirm you also get 60?
Yeah.
Let me know if you don't.
Yep.
Yep, good.
Yep.
Eden. Yep.
Yes.
Okay. Now, we're here, 60 degrees. We know sine is positive. So you would draw your little all stations to central. You have to do it every single time you are solving for trig. All stations to central. Is this sign positive or negative?
Positive.
Positive.
Oh, no,
So
negative.
no, it is positive. Why are you saying negative? Wait.
Because it was inverse.
Wait. No, that's negative one. That's the inverse. No, that's got nothing to do with the original question. So look,
Okay.
let's have a look at this. This is all positive. Positive. Look at this one.
Yeah.
Negative. This, when you go into minus the 1 to this side, it's probably going to become a negative. This one, when you square root it, you're going to have a plus and a minus. So there'll be a negative in this one as well. But right now, this is still positive.
Okay.
The original case is positive. All right. So it's in here and here. Right?
Mm-hmm.
The first answer you get is theta. That's for A. That's perfect, 60 degrees. The next answer is meant to be in sine, which is 180 minus 60. 120 degrees. Does that make sense?
Yeah.
Yeah.
Everybody? Yep. Daniel?
Yep.
Yep.
Brad?
Yep.
All right.
Yep.
Done. The only thing is, like I said before, it used to be like this. You have to solve your answers from 0 to 360, but now they're in radians, so up to 2 pi. So what we've got to do is just convert these. So divide by 180, and please make sure you get the same answers as me. That's that one. Next one, divide by 180 is 2 on 3, so 2 pi on 3. Confirm once you agree, and then I can move on. Or if you've got a question.
Yeah.
we'll do it.
All good.
Yep.
Beautiful. All right, let's go with B. and move b down here. That'll be easier. And x equals 1 on root 3. All right, Eden.
Yeah.
We're going to do this one together. You ready? So first step, x equals, what do?
10 and inverse 10.
Inverse tan, 1 root 3 equals, do it in your calculator,
30.
30. Then, what do we do just before you finish off here?
You draw the
Yes.
ASTC.
ASTC, all stations to central. Very good. Tan is positive. Where is tan positive? Here and here. The angle for this was theta. The angle for this was 180 plus theta. So what's the next answer we need to get? Theta meaning the first angle you get. So x or theta, whatever. What's the second answer that we need?
210 degrees.
Say that again.
210 degrees.
That's it. 210. And then final answer, you got to divide by 180 and give them as radians.
Mhm.
Daniel, does that make sense? Every line that I've done?
Yep.
Copied it all down?
Mhm.
Everybody's done? Move on?
Yep.
Yep.
Yeah.
C. C. Cos x equals negative root 3 on 2. All right. Negative root 3 on 2. Okay. Very important note here. You're going to hear me say, again, more than your teachers, because your teachers won't do it this way. We will not inverse a negative.
Oh.
So if you ever see a negative, we will not be inversing that. It must always be positive. Never inverse a negative. Okay? So when we're trying to find x here, we're going to put a little like inverted hats, and that's how I do my negatives. Inverted commas, I mean, or little hats or whatever. Anyways, so x equals, all right, what's the answer to inverse cos root 3 on 2?
30.
30 degrees. The reason why we do that is because when we're doing our all stations to central now, we've got to say, where is cos negative? Well, cos is negative. Lisa, where would cos be negative?
In S and T.
And why is it negative? Because obviously there's a negative sign right there, yeah?
Yeah.
All right, so S and T. But S and T, to be able to do them, you need 180 minus theta and 180 plus theta. Now, if you didn't have theta, wait, I just want to show you something. If you guys go ahead and try to put that negative in your calculator here, tell me the answer you get, and I'll show you the problem that you'll face. Yeah,
150.
150. See, you get 150, but the problem is when you're going to do 180 plus 150, it's going to get a bit too big for the answers we need. So you cannot put, so let's just say if it was 150, that was one of the answers. Then you're going to go and do 180 minus 150, you'll get 30 degrees, and then 180 plus 150, you'll get like 330. All right, let's see if that's true. We'll check on that soon. So back to the way I've said it. We're going to have these little inverted commas, x equals 30 degrees, right? Once you know that now it's cos is negative, so it's in sine and tan, your actual x is 180 minus 30 So the actual answer is 150. And the other answer is 180 plus 30, which is 210 degrees. And that is definitely not these two answers. You could say it is that answer, but then you're going to get stuck with the other half, so you're still going to get it wrong. So do not put negatives in your inverses. Is that clear? I'll know.
Your inverse?
I'll know straight away. Look, I'll know straight away if you're doing it my way or if you're doing your teacher's way, because your teachers will put negatives in their calculations because that's how your textbooks will teach it. It is not the best technique. This is the best technique. You don't put the negative in. You find your little x, then you just do everything the same way that you normally know it to be. 180 minus 30, 180 plus 30. So your two answers are these, and then I'll just finish it off, and then I'll take that question. 150 over 180, 5 pi on 6, 210 on 180, 7 pi on 6. Any questions now?
No.
No? Are we ready to move on to the next one?
Yep.
Yep.
All right. D. 2 sine x plus 1 equals 0. Okay. Well, obviously sine x is not the subject, so I've got to make it the subject. What are you going to do with this plus 1? What are you going to do with this multiplication of 2? Divide it. Okay. Again, we can't inverse sine a negative, so you're only going to write inverse sine of a half. You're going to put little hats to tell you that that isn't the answer. That's just part of the theta you need to work out. So this isn't the answer. These two are our answers. The same thing. This isn't our answer. It's just part of our working out. All right. What's inverse sine of a half? I get 30 degrees. Tiana, me and Jill will finish this off together now.
Okay.
You ready?
Yeah. So
right,
now.
here we go. So this x equals 30 degrees.
Yeah.
Walk you through it. Sine is meant to be negative. So where does that fall now?
In tan and cos.
That's it. So it's in this guy and in this guy. Do you know the answer for this one here, for tan? Do you know what it's meant to be? 180
180 plus 30
plus
degrees, which
theta.
equals 10. Oh,
Yeah. Yeah, and
Yeah.
this one here, what's this meant to be? 360.
360 minus theta.
Beautiful. And then, of course, the answers we need is x equals 180 plus 30,
Which equals
360 minus 30.
and 330.
Done. And then divide. So give me your answer for the first one.
I got 7 pi over 6 and then 11 pi
You're
over
right. Divided by 180 is 11 pi over 6. Good job.
Yeah.
Amazing. Done. I'll leave the rest, I think. Sorry?
So when
What was that?
like when you find out which quadrant it goes in, can you remove the this?
Wait, you gotta say that again?
When you find out which quadrant it goes
Yes.
in, do you remove the at things? Okay.
Yes, absolutely correct. So the hat's just there to tell you that is technically your theta that you're looking for. That isn't the answer that we're looking for. The answer becomes 180 plus the theta, so plus this angle. or 360 minus this. And we're only putting the hats there for the negative, so that you don't get confused with that being your answer compared to these two being your answers.
Oh, okay.
Good job. Like I said, I'll leave the next few for you guys to do at your own time. I'll go on to some of these harder ones. These ones, right. All right. Brad,
Yeah.
you're doing the first one with me.
I,
A, sine 2x equals 0.5. Now
Yep.
this one here, everybody, this one changes a little bit. The reason why it changes is because it's got a 2x. So we've got to do some extra stuff. But I'm going to try to keep everything as uniform as possible. So, Brad, what's your first step?
I'd shift sine half.
You are correct. So shift sine half, 0.5 becomes 30 degrees.
Good.
Can
And then
everybody
you get one.
confirm? Yep, and then all stations to central. Where is sine positive? Here and here. So 180 minus 30. Is that what you're going to say, Brad?
Yeah, 150.
All right, and then what now? Do you know what to do now or not?
Yeah.
No.
I think I'd half it. I'd divide it by 2.
You would soon. All right, so let's talk about this now.
Okay.
Yep, let's talk about it. So this 2x means that it's actually doing 2 revolutions. That's 1, and then it's going to go again. 2. So what we must do is add 360 degrees, right? Because a revolution. We add 360 degrees to these answers. So what's 30 plus 360?
390.
What's 360 plus 150?
510.
510. You only need to add 360 to the 2 answers you've got. You don't need to add more. So you should have, so pretty much it was like this. I mean, like, look, to go back up for a second, when you had x here, you had 2 sets of solutions, right? 1, 2. When you're going to have 2x, you're going to have 4 sets of solutions, double the amount. If it was 3x, you're going to have 6 solutions, for example, 3 times the amount, and so on. All right. So we added 360 to both of these numbers, and all we do now is finish it off, divide by 2. Brad, does that all make sense?
Yeah.
Yeah.
All right, we get these answers, and then all we do is just divide by 180 now. So the answers you should get would be pi on 12, 5 pi on 12, 13 pi on 12, 17 pi on 12. Any questions there?
Nope.
The only extra thing we had to do, the fact that it's 2x, you've got to add 360 twice, I guess, to this and this. So, I mean, once. You add 360 once to this and this. And then just divide by 2. You are not allowed to add 360 at the end. So a lot of students think they can divide by 2 and then add 360. That's not allowed. That's wrong. You have to add 360 before you do any further math. Okay. Let's try B. Who wants to try this? Lisa, should we do it together, you and I?
Sure.
Let's do it. Cos 2x equals negative 0.5. Okay. The first thing that worries me is what?
The negative.
The negative. So I'm going to write 2x equals, and then inverse cos of a half. You just do positive half. What do you get?
Mm. Mm.
Inverse cos of a half.
60.
60 degrees. Then we need to, before we can continue anything else, we need to actually work out what my 2x is, right? We don't want these halves. We actually want just 2x. Where is cos negative?
In T and F.
So what's my answer here? 180 minus this?
180 minus 60 and 180 plus 60.
Beautiful. So that becomes 180 plus 240. Now you've just done you've just done everything as if there wasn't a 2 there. Now what if there is a 2? What are you meant to do to both of these answers?
You add 360.
Add 360. And do you understand what I just said there? We just did everything normally as if there wasn't a 2 there. So you completely ignore that fact. Just here is when you add 360, add 360, 600. And then what are you going to do now, Lisa?
Divide them all by 2.
Easy. And then last line.
And then you put them all over 180 and put a pi on them.
Yep. Okay, put them all over 180 and then put a pi on it. Radian. Or radian form. 4 pi on 3. 380. So 2 times the angle, you'll get 2 times the solutions. 3 times the angle, you'll get 3 times the solutions.
Okay, that makes sense.
So yeah, it does. All right, again, please, I'm going to emphasize it one last time. Your teachers will actually do stuff to this. They'll make this into 2x 720 when they're doing these questions here. 2x 720. I will not do that. I did not do that. So if you relearn this at school next term, please rewatch this video before you learn a different method. D, cos x on 2 is equal to root 3 on 2. All right, this is not a 2x, this is an x on 2 this time. You get half the solutions technically. But we'll see. Kiana, let's try it together.
Yeah.
All right, next line, x on 2, and then you go on to do what to this?
I would take the 2 over and then times it.
Nope. That's an angle. Cannot do anything to that.
Count it.
You have to get rid of the cos.
Okay.
What are you going to do?
Inverse.
That's it. Inverse or shift. Cos.
Yeah.
I'm okay with either. Root 3 on 2. That gives me 30 degrees.
Could I divide that by 2 now? Times it by 2?
Not yet. Before
Okay.
you do anything else, you got to do all stations to central. Right after you find your first answer, you jump and do your all stations to central. Cos is positive, so therefore it's going to be here and here. 360 minus 30 is 330 degrees. Now, like I said, because it's half the angle, you are meant to get half the solutions, but watch. You times 2 now. Times 2. That's way too big, right? Because we were meant to stop before 360.
Yeah.
Look, less than 360. And that's why you only get half the solutions. So you only get one solution this time.
Okay.
whereas usually we're meant to have 2. If it's 2x, you're going to have 4. 2x, you're meant to have 4. X onto half of x, you're going to get half of 2 numbers, which is 1. One solution. Make sense?
Yeah.
And the reason why you get 1, just to make it clear again, when we times 330 by 2, it's too big. It's outside of our domain that we require. Right. B. 10x on 2 equals negative root 3. 10x on 2 equals negative root 3. So I'll do this one now. I see a negative, I get worried, I do it like this. I inverse tan, just the positive case. Inverse tan of positive root 3, my answer is 60 degrees. Then I do my all stations to central. I realize where tan is negative and it's here and here. So that means my actual x on 2 is 180 minus 60 and 360 minus 60. Then I times by 2, and I remember by times in this one by 2, it's going to get too large. So my only answer is x equals 240 degrees.
Do you have to convert them to again?
Oh yes, of course. Still used to the old syllabus. 240 over 180, 4 pi on 3 equals 4 pi on 3. Thank you for that. I think the same thing with the top one. Pi on 3. On 3. Everybody happy with that?
Yep.
All right.
Yep.
Technically, we are, other than the sine rule and cosine rule, which we will do next week, we are pretty much done. And like bearings and whatnot, we will do next week. We have completed the more important bits of trig. So that's good. I'll save these for you guys first. We'll call it Thursday. I'll share this file. I'll share this file to your Skype chat, and like I said, at the end of the lesson, you'll also get the recording. So, good. So next week we're going to finish off trig. What I'll do for the next 10-15 minutes is exam questions. So once you feel comfortable with a topic, like as I've always told you guys, get onto your exam questions, and now we actually get to do that. So year 11 advanced. Assignments and exams. Beautiful. Let's do 2002. Okay. Please, I don't know if I need to emphasize this with you guys over and over again, but you have to jump straight off as your function. That's the topic you guys have just done. You've got to jump straight to exams. Once you start feeling comfortable with the topic, you move right on to exams. So at least that way you're targeting specific exam style questions. Here it is. There's a show question, which looks fairly similar to the ones we've done. And there's a solve question. So I'm going to with that. We're going to try to do that now together. Okay. Show that tan theta plus cot theta equals 1 on sine theta cos theta. Okay. Hi. How do we start with show questions? Lisa.
Would you make the cot theta?
Wait,
Yeah.
not yet. How do we start it? You write L.
Oh, left hand side, right hand side.
Yeah, that's it. That's
Just
beautiful.
one.
You need to get used to that. LHS equals tan theta plus cot theta. All right, go ahead. Tell me. How do I change tan theta? What do I change it to?
That becomes sine over cos.
Yes. Was that memorized or did you have to look?
I looked.
Okay, that's fine. That's fine. Still the first day. Cot theta.
And that one becomes 1 over sine.
1 over tan, you mean?
Oh, yeah. My bad.
But you're not going to use that one because you can see the answer is all in terms of sines and causes, so you're going to use the other one. What else does cot theta become?
Sine over cos.
Nope, other way. Cos over sine.
Oh.
Have you
Okay.
written it down properly?
Yeah.
Okay, so tan is sine on cos, cot is cos on sine. Okay, now what are you going to do?
Make a common denominator.
That's it. And again, just cross multiply, that becomes sine squared plus cos squared. What does sine squared plus cos squared theta equal to?
1.
1 on cos sine. Does that look like the right hand side?
Yeah.
Done. You got yourself 1 mark in an exam. Simple. See how you don't need to, see how all of you, see how you don't need to do 1,000 textbook questions? Once you start doing a few and you understand the concepts, you know the formulas, you jump straight to exams. This is what I've been talking about. You have to jump straight to exams. No point of doing textbook questions. There you go, you got 1 out of 1. Double I. All right. Hence or otherwise solve this. Hence or otherwise. All right, obviously you have to use this. So for this guy here, tan theta plus cot, we've got to use 1 on sine. Worth 3 marks, which means it's going to take us some time. Here we go. Solve. 1 plus cot theta on cosec theta minus sec theta on tan plus cot equals 1. We're trying to solve this one. All right. Shall I start? Let's do this at 10. All right, here we go. Cot theta. What does cot theta become? Eden. What does cot theta become? Do you know?
Cos over sine.
It does become cos over sine. So let's go 1 plus cos over sine. All over. What does cosec become?
1 over sine.
1 over sine, the third letter. Good job. 1 over sine. Minus sec theta. What does sec theta become? And plus cot plus there. We will first get this one. Add this.
Hello.
Yeah, can you hear me?
Yeah, I can hear you now.
All right. Tell me.
Okay.
All right. What are we up to?
I was just trying to mute someone else's. Okay, perfect. This one here. Does,
Where do we go from here? Okay.
does this line
Let's
make
just
sense
go.
first?
You go cos on sine times sine on 1.
Yeah, well,
Top
hold on,
half.
hold on. Does this line make sense?
Oh yeah, yeah.
Everybody, does the line make sense? All
Yeah, that makes sense.
Yeah.
right, Neil as
Yeah.
well saying.
Yep.
All right, so I changed each one. Okay. Um, now, Rad, yeah, go ahead. What are you going to do with this guy first?
You're gonna solve that, and then you'd put what is it? You'd go cos on sine times sine on 1.
Say that again. You'll go cos on sine times sine on 1. Oh, yeah, I see what you're saying. No, you have to make this into a common denominator first before you do anything here.
Oh, sorry. Yeah, I forgot about
Yeah,
that.
so this one here, this second fraction, since it's one fraction over one fraction, yeah, you can multiply by the reciprocal, whatever. This one here, you've got two fractions at the top, technically, right? 1 over 1 over another fraction, and that's not allowed. So what you've got to do here, make it a common denominator first. The next line will look like this. All over sine theta. Do we agree with that?
Yep.
Everybody else?
Yeah.
Yeah, okay.
Yeah.
Yeah.
Over 1 on sine. Ugh. Minus, okay, this monster. 1 on, I'll just write it like this for now. Equals 1. All right. Now I'm going to split it up because I think it's getting a little bit too big. So what we're going to do is just do this left bit. So left bit, you would write it like this. Sine theta plus cos theta on sine theta times what? What did you say, Rad? Times what?
Sine on 1.
Sine theta on 1. This and this cancels, and you're left with
Yeah.
everybody happy with that?
Yeah.
No?
Yeah.
So here, when we're dividing by 1 on sine, you can't divide by a fraction. What do? You multiply and flip.
So,
Yeah, the reciprocal.
Okay.
Yeah.
Yeah.
And then same thing with this guy. It's going to be minus 1 on cos, which is the numerator, times reciprocal of this, which is
cos theta sine theta.
Sine theta.
cos theta sine theta. Yeah, which becomes
Sine
Sine
theta
theta.
equals.
Oh my god, after all that, look what happens. These guys cancel out, and all you're left with is to solve cos theta equals to 1, which is super easy. Shift cos of 1 is 0. Then you do all stations to central, and you just get 360. So your answer is 0 and 2 pi. So the solving, just so you guys understand something, the solving bit was easy. It had nothing to do with solving. The whole point of this question was the algebraic manipulation, like this, all this bit. To try to move from algebraic fractions to simplifying fractions, multiplying, dividing. I would recommend reviewing that in the video because that is pretty intense.
Yeah.
But that's exams for you. All right, I'll save that as well for you guys and I'll send that across. Save. All right. Straight line graphs. There you go, there's a Clancy paper. All right, I might leave it there. I'll send you guys some, wait, first, before, let me close this. Apply later, go here. Let me send everything in conversation. So at least I know you guys have got this. All right, your homework, really basic homework, right? Just go to this file. Don't start from exercise 2. We started from exercise 3, and actually try to answer the questions. What I might do, I just realized I sent this copy. I'll try to send you the original copy as well. But exercise 2, exercise 3, and exercise 5. 3, 4, 5. 3, 4, 5. Let me